Hello students, today I am going to tell you about the chapter motion. Okay, so first of all, what is motion? So if an object is in ideal position, okay, it means if the object is in rest position, it is not moving, then we can call it in a rest position. Okay, but is there is any movement, any change in position we will found, then it is in motion. Okay, so what is motion? We'll say motion is a change of position. So it can be described in terms of the distance moved or the displacement. Actually the motion is the movement of an object. Okay, now what is origin? To describe the position of an object, we need to specify a reference point, that is called the origin. If we want to calculate the distance between two objects, how we will, if okay, that is how we will calculate. We will take one point as a reference and then we will calculate the other thing. If we are randomly, anybody told us that you have to calculate the distance of your home, so we will ask them from where, right? From where we need some reference point from where we have to calculate the distance. Okay, so we need an origin to describe the position of an object. Okay, now displacement. Displacement is the shortest distance between 2 points. Okay, and distance is the total path length. Don't confuse between the displacement and distance. Don't confuse between the displacement and distance. Displacement is the shortest length between the 2 points, and distance is the total path length, total covered distance. Now let's study with the help of this example. Suppose there's a man who's standing in point A. So this point A is the origin. Okay, if he's moving from point A to E, then to C. Okay, then our distance will be from A to E, then C. Distance will be 70 plus 40, then 110. But displacement, the shortest distance between the initial point and final point. Okay, so initial point is A and the final point is C. The shortest distance between A and C is 30 meters. So the displacement will be 30 meter. 30 meter, centimeter, whatever, just the magnitude we are taking. Now let's go to the circle. If a man started his journey from point O and then again go through the entire circle and then again reach to the point O, what does it mean? It means the initial point and final point both are the same point, that is O. It means the displacement will be 0 and this distance will be the total path length, that is the circumference of the circle, 2 pi r. Okay, now if object is in motion, then there is two kind of motion. Okay, maybe the motion is in uniform, the object is in uniform motion, or the object is in non-uniform motion. Okay, then we will see what is uniform motion and what is non-uniform motion. Let's start. We will study with the help of this graph. Give a look on this graph. The graph is a distance and time graph. Okay, if an object moving in a straight line and cover equal distance in equal interval of time, it means if the time is changing 5 minutes, then same distance will again cover in the next 5 seconds. Okay, so let's see. The first we have taken the 5 second. Okay, within this 5 second the distance covers 10 meter. In the next 5 second again the distance covers 10 meter. It means equal distance in equal interval of time. Okay, there is an interval of 5 minutes and the distance is also 10 meter in each interval. So the equal distance in equal interval of time, this is called uniform motion. Same we will see non-uniform motion. There is unequal distance in equal interval of time. Okay, there is a first 5 second the distance cover is 10 meter. In the next 5 second the distance cover is 30 meter. Yes, 40 minus 10, that is 30 meter. Okay, so unequal distance in equal interval of time, this is called uniform motion. Now we will see with the help of this chart. This time is 9:30 a.m. then 9:45 a.m. then 10 a.m. It means there is an interval of 15 minutes in each time, right? and the distance traveled by object A in meter. At 9:30, the travel distance is 10 meter. 9:45 distance travel is 20 meter. 10 a.m. the distance travel is 30 meter. It means there is an interval of 10 meter. For every 50 minutes, the distance covered is 10 meter. It means equal distance and equal interval of time. So the distance traveled by object A is in uniform motion. Let's see about the object B. At 9:30, the travel distance is 12 meter. 9:45 distance travel is 19 meter. 10 a.m. distance travel is 23 meter. So we can see that there is a unequal distance travel in equal interval of time. So the distance travel by object B is a non-uniform motion. Okay. Now average speed. So we are very much familiar with the word speed. Speed is equal to distance by time. Distance covered per unit time. Okay, that's a unit of distance. For speed is meter per second or kilometer per hour. The average speed is distance traveled by total time taken. Average distance we have to take as a, this is not possible that if we are going from one place to another, then we are going in a same, we have to move in a same speed. This is not possible. Sometimes we move in fast, sometimes we are moving some slow. So we have to take the average speed. If you want to calculate the speed, okay, we will take as average speed, that is distance traveled by total time taken. Let's see with the help of example. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? The total distance traveled by an object is 60 meter plus 60 meter, that is 32 meter. Okay, and total time taken is 4 seconds plus 2 seconds, that is 6 seconds. So the average speed will be 32 by 6. Okay, distance by time. Now velocity. Okay, speed and velocity both are same. Both are same in the sense in magnitude. But if we are talking about the direction, the we will not talk. The speed will not work in that case. We have to say that the velocity we have in that case velocity will come. Okay, the velocity is the speed of an object moving in a definite direction. Actually velocity is a vector quantity. We are taking magnitude as well as direction, both are taking account in this velocity. Okay, but if we are talking about the speed, only magnitude we are talking about. Okay, speed का डायरेक्शन से कोई लेना देना नहीं. Okay, in one line. Now velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. Of course, they can be uniform or variable. It can be changed by changing the object speed, direction of motion, or both. I have told you already that if the speed changes, the velocity will change. If the direction of motion changes, the velocity will change. Or if both are changed, then of course velocity will change. Now, what is average velocity? Average velocity is initial velocity plus final velocity by 2. We denote initial velocity with U, final velocity with V, okay, by 2. Now, average velocity is also displacement by total time taken, that is displacement per unit time. Velocity is U plus V by 2. Speed and velocity both have the same SI unit, that is meter per second. Okay, velocity time graph for uniform motion is like this, and for non-uniform motion is like this. Okay. Now acceleration. Acceleration is a rate of change of velocity. Okay. Velocity if we are if the velocity is changing, okay, time with the time, then this acceleration is come. The rate of change of velocity is acceleration. Acceleration is taken to be positive if it is in the direction of velocity, or if and it will be negative if it is opposite to the direction of velocity. SI unit of acceleration is meter per second square. Actually, the formula of acceleration is v minus u by t. Okay, v minus u by t. Now, example. Starting from a stationary position. It means initial position is 0. Okay. Now Rahul paddles his bicycle to attain a velocity of 6 meter per second. Final velocity is 6 meter per second. and in 30 seconds, time is 30 seconds. Okay. Then he applied brake such that the velocity of bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of bicycle in both cases. Okay. In first case, u is equal to 0, v is equal to 6 meter per second, and time is 30 seconds. So acceleration is v minus u by t. So 6 minus 0 by 30. Okay. In second case, the initial velocity is 6 meter, as the cycle is coming with the velocity of 6 meter per second, right? And then brakes, then you apply brake, and then velocity comes down to 4 meter per second. It means the final velocity is 4, initial velocity is 6, and time is 5 seconds. So we calculate the acceleration, but acceleration will be in negative because there's decreasing velocities decreases, right? Equation for velocity time relation. There's 3 equations that is very important for the numericals, right? So we will see with the help of the graph. We will make a graph of time and velocity. Okay, there is the initial velocity is a. Okay, point a to b is our is the movement of an object, right? So here we will draw a perpendicular line from a and b, that is eb and ad. Okay, no problem within this. And then we will draw parallel to line AD, that is parallel to OC. Okay. Now from here we can see that BC is equal to BD plus DC, and BD plus DC is equal to AO, right? We can write it as a BD plus OA. Okay. Now, as I've told you, this BC is final velocity V, right? And OA is U. So we can write BC. In place of BC, we will write V. V is equal to BD plus U. So BD is equals to V minus U. Now we know that acceleration is V minus U by T. I've told you now. Then V minus U by T, the acceleration. This AB is actually acceleration, right? If we are taking the graph of talking about the graph of velocity and time, this AB is line is acceleration. Acceleration V minus U by T, that is BD by AD. No problem in this. Now BD is equals to A into AD. Okay, we know that AD is equal to time, right? AD is our time. So BD is equals to 80. Now we are combining both the equation, and we will found that V is equals to U plus 80. Okay. Now, equation for position time relation. The total distance traveled by an object is obtained by the area enclosed within OABC, that is the area of trapezium. And to find out the area of trapezium, we will add up the area of triangle and area of rectangle. The area of triangle is OABC, is the area of trapezium, is equal to the area of rectangle OADC and the area of triangle ABD. Okay, now we know the formula of rectangle. We have to calculate the area of rectangle, that is OA into OC, length into breadth, right? Plus the area of rectangle, half into base into height, half into AD into BD. Now substituting the value, OA is equal to U, right? A is our initial velocity, and OC is equal to AD equal to T, okay, and BD is equals to AT. Then we get S is equal to UT plus half AT square. Now circular motion. One formula I have missed. B square is equals to U square plus 2AS. Okay, that you will do it. Now circular motion. When an object moves in a circular path with uniform speed, its motion is called The motion is called the uniform circular motion. Okay. Distances, if we are going through the circular path, the distance will be 2 pi r, right? And as we are talking about the motion, means it is a speed. So divided by t, that is distance by time. Okay, so the circular motion is 2 pi r by t. Okay, thank you. That's all for today. The rest numericals we will do in the next video. Thank you.